Hey guys, this is Professor Janacek. Want to talk about a convergence test. Want to go specifically over the direct comparison test. Now, this is usually simply called the comparison test, but I like to call it the direct comparison test so you don't get it confused with the limit comparison test. So this test says we're looking at a series, and if my a sub k's are less than some b sub k. Now we're going to have to find that b sub k, but the a sub k's are smaller than the b sub k's, and the b sub k's converge, then we know that our a sub k's also converge. If the b sub k's are less than the a sub k's, and we can tell that the b sub k's diverge, then the a sub k's also diverge. So let's take a closer look at what that means. Starting with the first one. I find some b sub k's, but the a sub k's are smaller. So the a sub k's are smaller than the b sub k's. And the b sub k's converge. So the b sub k's converge to some number. Well, it turns out the a sub k's can't go crazy and diverge. That's just not going to work. So the a sub k's must also converge. Now they don't necessarily converge to the same value, but they're also going to converge. If we turn those around, if it turned out that the a sub k's were larger than the b sub k's, but the b sub k's also converge, what would we know about the a sub k's? Well, the a sub k's might converge, but they might also diverge. We just don't know. Looking at the second situation, where the b sub k's are smaller, so our b sub k's are smaller than the a sub k's, we also know that the b sub k's diverge. The b sub k's go up and diverge. Well, what about those a sub k's? Could they converge? No, that's not going to work. So it turns out the a sub k's must also diverge. What if they were turned around? What if the b sub k's were larger than the a sub k's, but the b sub k's also diverged? What would we know about the a sub k's? Well, they might also diverge, but they could also converge. We don't know. So we only know for certain cases. Let's try some examples. Let's take the series where we have k goes from 1 to infinity of k cubed over 2k to the fourth minus 1. Now, we're going to start with our terms. K cubed over 2k to the fourth minus 1. These are the a sub k's. That's what we're given. We have to find some b sub k's. Well, let's take a look at k cubed over 2k to the fourth minus 1. I'm sorry, not minus 1, just without the minus 1. Notice that this has a smaller denominator, which means that overall it's the larger fraction. So the a sub k's, in this case, are greater than the b sub k's. All right, the a sub k's are larger, so I'm hoping that the b sub k's will diverge. Maybe. If they don't diverge, then I can't tell you anything. But if they do diverge, then we know the a sub k's will follow suit. All right, well, let's go ahead and simplify this. K cubed over 2k to the fourth reduces to 1 over 2k. And now I'm going to take a look at that series. k goes from 1 to infinity of 1 over 2k. Notice I'm just taking this and writing it as a series rather than a sequence. Also notice that I can factor out this 1/2. And let me go ahead and put an exponent of 1 there because that looks familiar to me. This is a p-series. Specifically with p equal to 1. And when p is equal to 1, we know that this diverges. Yay, that's what we wanted, right? So, the b sub k's diverge, which means that my original series of a sub k's also diverge. Let's try another one. Let's take the sum as k goes from 2 to infinity of the natural log of k over k cubed. Now it's not a problem that we're starting at 2. As long as we're starting after 1, you'll notice my series has to start at 1 or past that. I'm going to first look at my a sub k's, the natural log of k over k cubed. These are the a sub k's. We have to find some b sub k's. Well, I'm going to take a look at k over k cubed. In this situation, looking at just the numerators, I want you to think about those graphs. You'll notice that eventually, as k gets really large, the graph of natural log of k versus the graph of just k, k actually ends up being larger, right? And you can think of those in terms of x, y equal to the natural log of x versus y equal to x. But in this case, the natural log is the smaller one. Notice the denominators are the same. All right, so in this case, we've got my a sub k's are smaller. So I'm hoping that these b sub k's will diverge. I'm sorry, will converge. Let's take a look. We can reduce this to 1 over k squared. And now we'll look at that series as k goes from 2 to infinity. Yes, I'm leaving that 2 as the beginning of my summation. And I'm now going to look at the b sub k's, 1 over k squared. Well, again, if we look at this, it's easy to tell that this is a p-series. In this case, p is equal to 2. Well, p is equal to 2, which is greater than 1, which means that this series actually converges. Yay, that's what we wanted. We wanted this to converge. If the b sub k's converge, then my original series of a sub k's also converges. I hope that makes sense. Enjoy!